Hey guys, welcome back to Tech Samadhan. We have started with machine learning series. We understood what is supervised learning and algorithms. Yeah, there are a few algorithms which I haven't explained, which was the random forest, support vector machine. But definitely I will explain it in our algorithm series part. Moving forward, we have know that what is unsupervised learning. That is, we provided an unlabeled data and it predict by understanding the underlying pattern with that data. Now there are algorithms for unsupervised learning also. So this is there are like in supervised how it is classified into classification and regression tasks. Here it is classified into clustering, and different types are also present for unsupervised learning. So we'll focus now on K means clustering, or what is clustering is. So clustering is primarily used for unsupervised learning. Now unsupervised learning requires exploring given data set, as you know. Clustering analysis is a technique of partitioning a given set of unlabeled objects having many attributes into meaningful disjoint group. So what we will do here, we will classify our data. So for example, we will classify this data into a cluster, into a disjoint sets. This is the theoretical or an technical explanation I have got you here covered. So clustering is grouping unlabeled example or sample. This is done using trial and error as there is no label data. The input to cluster analysis is samples. Now, clustering, as it is said, that clustering is grouping unlabeled examples. This is the algorithm how it works, and this is the definition for K means clustering. And clustering is grouping unlabeled. So whenever there is an unsupervised learning, the data is unlabeled. So it is grouping unlabeled examples, or we also say it as samples. This is done using trial and error as there is no label data. The input to cluster analysis is sample or example. Now input to our cluster analysis is sample, or we can say examples. So this is our input to clustering analysis, and output to the clustering analysis is then, like, there is input to cluster analysis, and they are also known as samples examples. They are basically object or data point, but these are unlabeled. And output is set of cluster of similar data. So it is set of cluster of similar data if it is found in the input. So when we will find an output, if it is found, or if it identifies the pattern in input, because we don't provide label. We don't provide label data set. We just provide the data. So these are the samples or example, which are basically some data point in technical terms. And output is set of cluster. Cluster means the points, like the groups of similar data if it is found in the input. Moving towards now the coding example, like you would just imagine. So why clustering? So we need to group data. So we do it manually. So there we can have a stop. So have you ever wondered how Spotify create music playlist based on your listening habit, or how customer segmentation works in marketing? That's power of unsupervised learning, especially K-means clustering. So K-means clustering is one of the most powerful and widely used unsupervised learning technique to group data based on similarity without any labels. So don't confuse with the previous video, which is K nearest neighbor and K means clustering. The main difference itself is one is the supervised learning algorithm and one is unsupervised learning algorithm. So that's the main difference you need to understand. Okay. And in this video, we'll explore how K-means works, when to use it, and the numerical example of it, as we did in the previous example, which is K nearest neighbor. So this is the algorithm step. So here also we need the value of K, but as in K nearest neighbor, we need to know its nearest neighbor. Here we need to know the cluster, the centroids we say. So you can have a look over it, how the algorithms are what is the step we require to do? We can imagine K-means clustering as Lego blocks mixed with different shapes and colors. You want to organize them into groups, but no one tells you how to group them. So that's the unlabeled data. We have the input, but no with no label. So here we decide to separate them based on similar shapes, like triangle in the triangle group, square in square group, circle in circle groups. That's how unsupervised learning works. Technically, the model is given input data without any label or categories. The goal is to find patterns or similarities in data and group them into meaningful clusters. No human intervention is required. The model figure out on its own. So what does clustering then? So as previous we have the fruits example here also. We have a basket of fruits, apple, oranges and bananas. We don't know which is which. Like we don't know this one is called apple, this one is called banana. We just have the fruits. But you can figure it out based on their shape and color. That's clustering, grouping similar things together. So here clustering grouped based on similarity. Data points are grouped based on similarity. Keep in mind this line. Data points with same cluster are highly similar. So which are in one group, they are highly similar. And one in A group, one in B group. So they are in different cluster. So they are different. They are very different. So there are three types of clustering method. K-means clustering, group data into clay clustering using centroid, mean shift and Gaussian mixture model. So we'll see only K-means clustering here because it's more popular algorithm in unsupervised learning. So how it works or what is the algorithm steps? We can show it here. So we need to choose the number of clusters, that is k. So whenever we or whenever anybody tells choose number of cluster, that's nothing but k. Randomly place k centroids. Centroids nothing but the center point in data set. Assign each data point to nearest centroid. So here also we will use the Euclidean distance. We'll recalculate the centroid. I will show this recalculation of centroid. What does this means in the numerical example? There you would understand it very easily. And we need to repeat the steps 3 and 4 until centroid stops changing. Until they stops changing means until they stops being in the same cluster. So here we have an example where the input we gave to this example is the annual income and spending score, and goal is we need to group customer into segment for better targeting. So here I have imported all the important libraries. Now this matplotlib is used for visualizing the graph. It is also most powerful library. I will have one video over the series of all these libraries in machine learning we use. So don't worry about it. So here, this is an example data, annual income and spending score. 3 cluster, now where K is 3 now. Now we will predict the cluster, to which cluster the given data falls in. Now we will, and there is the, we are just plotting it. So yeah, so I hope you can see this. मग काम चालू आहे माझं. दार बंद कर, काम चालू आहे माझं. अगं काम चालू आहे, कळत नाहीये का तुला? So you can see if this window is visible to you, or else I will show you in the last after explaining the numerical example. So this is the graph we got, and those in the same color belong to same cluster. Okay. That's how we can visualize it. So model groups data point into 3 clusters based on similarities. Centroids are recalculated until they become stable, and model predict which cluster each new data points belongs to. We can use the k-means clustering for customer segmentation, document classification. So there are numerous ways to choose the number of clusters or the k. So elbow method is there, and different methods are there. I will explain this also in the upcoming videos. Advantage of k-means are simple and easy to implement, fast for small and medium data set, and works well with clear clusters. It is sensitive to outliers, and non-spherical clusters won't work. We need to normalize data before using k-means. To select k, here we use the elbow method. Now we will move towards, as I said, into the numerical example and what is the recalculate the centroid means in the k-means clustering algorithm. So we will move towards it. So yeah, this is the numerical example for k-means clustering. The previous video in the k nearest neighbor, we saw that example, numerical example for classification. Now this is for the k-means clustering. So consider the following data shown below. Use k-means clustering. Now here the k value is predefined. Now this for clustering to know the k value, there are numerous methods, and as I spoke about the elbow method, I will explain what elbow method is. But now for this example, k is it is given to us, and these examples are very important in the engineering exams, in the machine learning. If you have some data visualization course you have undertook, so these are the important example and which will surely give you 5 to 10 marks. So yeah, it is the sample data. Now we will consider this 3, 5 because they haven't provided us the centroid. So we only use this 3, 5 and 7 and 8. Okay. Now this 3, 5 and 7 and 8, we will only use this as a centroid. So this 3, 5 and 7 and 8 we will use as this centroid. You can see here that this 3, 5 and 7 and 8 are used as the centroid. These 3, 5 and 7 and 8 are initial centroid we have choose. Now this step 2. Calculate centroid by making two cluster 1 and 2. So we made two cluster 1 and 2. These are the centroid we took from the data itself 3, 5. So these are the two cluster now, and these are only the two centroid. Now using the Euclidean distance, which is having this formula as x minus x1 whole square plus y minus y1 whole square. So using this Euclidean distance formula, we will calculate the clusters now. Now we will take this data point 12 comma 5. So see here iteration 1. Now this 12 comma 3 minus 3 and this. So the our value is now 9. Okay, now our value is 9. You can see here the value is 9 for it. Now this where this 12 5 3 comes from. Now that is nothing but this 12 5. We use this centroid first 3 comma 5 and this formula, which means 12 minus 3 plus 5 minus 5. You can see here. Now again using this point only, which is 12 comma 5, this point only, and the centroid 2 we will use 7 comma 8. We got the distance as 5.83. Now out of this 9 and 5.83, this is the smallest one. So hence the sample 3 is closest to centroid 2, which is 7 comma 8. So this sample 3 is now closest to centroid 2, which is 7 comma 8. On the similar basis, we will calculate for 16 comma 9 with this two centroid only, and we will see we did the calculation using that formula. Now the distance came out to be 13 and 9. Now again, this 9 is smaller, so sample 4 is again closer to centroid 2. Now updated table is cluster 1 has 3 comma 5, as you can see. Yes, it also has 3 comma 5 at this start point, but now it has shifted. The centroid 2 has been shifted. The cluster 2 has been shifted. Now so cluster 2 has 7 comma 8, 12 comma 5, 16 comma 9. Why these two are provided in this cluster? Because we found that minimum distance is from the centroid 2, and therefore important step to keep in mind, now our centroid 2 will get updated. We will calculate the average. So we will calculate 7, 12, 16 comma for y coordinate, for x coordinate 8, 5, 9. Now the new centroid, the centroid shift is this. That's what the recalculate the centroid step means, because these data points are now towards the cluster 2 because they are the nearest to them. They are the similar to them. Okay, so they are in that same cluster now. Now this is our shifted or updated centroid. Similar basis will calculate with the samples now. Now this 3 comma 5 3 comma 5. So the first distance would be 0, and from centroid 2 it is 8.9. So definitely sample 1 is close to centroid 1. Now with this centroid we'll calculated this. Now with this centroid we'll calculate for 7 comma 8. Now see. Now again here 4.71 and 5. Now the sample from centroid 2 only, the sample 2 is closer. Now for the sample 3, we calculated with the centroid 1 and the updated centroid 2. Okay, you can see here our centroid points and the sample is 3. Now you can see here 2 and 9. Now definitely for the sample 3 also they are closest from centroid 2. And last is the sample 4, which is 16 and 9. Now we'll calculate that for 16 and 9. With centroid 1 the distance is 13.6, and with centroid 2 the distance is 4. The sample 4 is also closer to centroid 2. Now the updated table we can see it's same as it is after iteration 1. So this is the table after iteration 1, and this is the table after iteration 2. Exactly same. Cluster 1 has only 1 sample point, cluster 2 3 sample point. So since the table 3 is same to table 2, there is no sample from table 3. So this table 3 sample, they haven't changed their clusters. So the algorithm is terminated because no samples from table 3 has changed their clusters. They remained with cluster 2 as they were in the table 1. So no sample changed their cluster. And hence that algorithm is terminated. Now the sample or the data points are partitioned into two clusters. So this is how they are partitioned into two clusters. So hope you have understood what k-means clustering is. I have explained it to you in the algorithm, the coding part and the numerical part. So if you like this helpful, then hit like, subscribe and comment k-means masters. Thank you.